This section is the last shot to the problem we have discussed so far. I mean that manufacturing challenge that we are working on. And in fact, we are going to make our first mathematical model based on that scenario that now you should be quite familiar with based on the discussions we have had so far. Okay, the first step to make our mathematical model is defining our decision variables. Let me tell you, everything that now we are discussing to make our mathematical model, you already know about. We are just talking about the specific standards that you have to put your thoughts on the paper accordingly. Here, it talks about the decision variables. You already know what are the decision variables. Here, I have bring again for you the definition of decision variables, controllable inputs, decision alternatives specified by the decision maker, such as the number of units of a product to produce. So, as you can see, first of all, it is controllable. It is something that you can control. It is something that you need to decide upon. It is not something that you cannot do anything upon. Another thing is that specified by the decision maker, and such as the number of units of a product to produce and like this. So again, review the model that the problem that we are discussing. In that situation, because here we talked about controllable inputs. What are the uncontrollable inputs? They are the profits, that 9, 10. They are the times available in each department. There are the times needed for each process, for each unit. They are uncontrollable. But what are the controllable inputs that are decision variables? They are the number of production that we will have. Let me give you some sort of help to how to recognize the decision variable easier. Decision variables are that part of the problem that you want this system tells you about. For example, when you are using your GPS on the car, what do you expect from the GPS? You expect the GPS to tell you what streets to take, and that's it. So decision variables in a GPS, because that's also a mathematical model, and we will discuss it in future, and you will learn what is the logic behind these wonderful tools that we use in our everyday life. So in that problem, decision variables are the streets. It should tell you which streets to take. What is the objective function with your GPS? Minimum time, minimum cost, minimum traffic, something that needs to be minimized. Here, because sometimes you confuse definition of decision variables with some other thing. Decision variables are the things that you want, that help tells you about. When you use GPS, you expect the GPS tells you about the streets to take. When you are using a decision support system in your factory, you expect it to tell you how many product you should produce. So it should tell you, for example, from the product 1,000, from the product 2, 2,000, from the product 3, 3,000, and so forth. So decision variables are something that are under the decision maker control, and you want to specify them to be able to achieve the objective function. Okay, here we have two Prada standard bags and deluxe bags. So the decision variable would be the number of standard bags produced and the number of deluxe bags produced. Let's name the first one X1 and the second one X2. In fact, in the previous section, instead of X1, we put 15, and instead of x2 we put 30. And here we just change it to x. Why? Because they are unknown. The next step is defining the objective function. When you define the decision variables, the rest would be very easy. The objective function, again, according to the definition that I have put for you here, a mathematical expression that describes the problem's objective, such as maximizing profit or minimizing cost. It is very obvious that in our case, the objective is maximizing the profit. We don't know how many standard bag, how many deluxe bag, but we know for each standard bag the profit is 10, and for each deluxe bag the profit is 9. So the total profit would be 10 times x1 plus 9 times x2. You experienced it. You just did it in the previous section, if you remember, with the number 15 and 30. It is exactly the same thing, just instead of putting fixed constant numbers, now you are putting your decision variables, because after that you are going to give it to the computer, and computer would solve it for you and give you how many product you need to produce. After that, we have the constraints. The constraints that we have is this. The definition says a set of restrictions or limitations such as production capacities. Here the capacity are bound by time, and here we have 4 processing sections, department, that we need to put a constraint for each of them. We know that the amount of time consumed by cutting and dyeing section is 7/10 x1 plus x2, because for each standard bag we need to spend 7/10 hours, and for each deluxe bag we need to spend 1 hour. So the total amount of time we need to spend on cutting and dyeing of our production package is 7/10 x1 plus x2. And the total, this total should be smaller or equal than 630, because it's the total availability of time in this department. Based on the same logic, you do the rest of the constraints here and finish. When you are done with the understanding of the problem, it would be very easy for you to develop your mathematical model. Starts with decision variables, objective functions, and after that, constraints. Now we are done with the mathematical model, but here the full mathematical model is presented to you, as you can see in this slide, but there are trivial differences. I have done it on purpose because on one hand, I want to tell you the fact that we decided to denote standard bags, the number of standard bags by x1 and the number of deluxe bags by x2. It doesn't mean it must be with x1, x2. You can denote it with anything. For example, in your textbook, they are denoted by S and D. S for standard bag, and D denotes for deluxe bag. And as you can see, it's maximizing 10S plus 9D. So it is the objective function. Here you see subject to, that is abbreviated with ST. And after that, you see the constraints here. Exactly the same as before, just the notation is different. That doesn't matter. Whatever you are more comfortable with, you can do it. And just you see some extra constraint here that we didn't discuss before, but it's the simplest constraint? Absolutely. When you are giving the things to the computer doesn't have any understanding of the things, and everything is based on the mathematical model. I mean, computer doesn't know that the numbers of production of a product should be a positive, so you need to specify it. So here it says that S, that is the number of standard bags produced, and D, number of deluxe bags produced, should be a positive number. All the problems that we discussed this semester must have this positivity constraint for all the variables. When you have this model, it's easy to give it to computer and solve it and get the results. The result that you get from solving this model tells you how many standard bag and how many deluxe bag you have to produce to make your objective function maximized. That we will discuss all the things later. Thank you.